Hello, everyone. My name is Andran Ali, the Bazooka Prophet, a passionate chemistry tutor with over 10 years of teaching experience. I've helped a lot of students master chemistry in a very simple, engaging, and easy manner. And today is another very interesting video on chemical kinetics. And this aspect is talking about the order of a reaction. Now, the order of a reaction isn't just a theory, it is very useful in the field of medicine, in the pharmaceutical industry, and even by industrial chemists to better understand how your drug works and so many aspects. Now, today we're going to be talking strictly on questions that borders around the order of a reaction. I will start with the definition of the order of the reaction. Now we should understand that the order of a reaction under chemical kinetics simply means the sum of the powers of the concentration of the reactant, the sum of the powers of the concentration of the reactant. Now, meanwhile, in our previous video, we actually talked about the rate of a chemical reaction, where we said that it can be written in two ways. That it can be written in two ways. One, based on the disappearance of reactant and appearance of product, and that secondly is based on the rate law. And based on the rate law is what involves to us the order of a reaction. Please do take note. It is actually very easy. Actually very easy. Take this from me for free. Now, we've defined for us what we call the order of a reaction, which we say that it is the sum of the powers. Now, take note. We said it is the sum of the powers to which all reactant concentrations appearing in the rate law are raised. That is to say, if I'm having something like, let's say I'm having 2A plus B to give me C plus D. Now, look at it. In the case of the disappearance of reactant and appearance of product, we write the rate of that reaction for each of the components. But in the case of the rate law, we only write for the reactant. Please take note of this fact. Take note of this fact. Now, if I'm to write the rate of this reaction, be very careful. The rate of this reaction is equal to the rate constant K with the concentration of the reactant. Here is A and here is B. Now, the powers here is X and here is what? Y. Do not be confused. The power of A cannot be 2. Why? The order of a reaction, please take note, the order of a reaction can only be gotten by experiment or by experimental data. Take note, the order of a reaction, it is common in most A-level exams that I've examined and I've supervised, that the order of a reaction can be obtained only by experimental what? Data. Experimental what? Data. Meaning, here is X and Y, which is the unknown. Now, to get the order of this reaction now, it is simply the order of the reaction is simply equal to X plus Y, which must be determined by what now? Experimental what? Data. If that is understood, then we can solve all the questions here. Now, we have different types of order of a reaction. When the power we got is 1, it is a first order. When the order we get, or when the power we got is 0, it is a 0 order. If it is 2, second order. If it is 3, a third order. We can also have fractional order. They all make sense. Now let us answer these questions for A level right about now. Now, very easy for us to address. Now, the first one is the question says, in each of the rates law below, determine the order of the reaction. This is the first question. Now, the order of this reaction now is simply the addition of the powers. Now we come here. The power of A is what? Which is, let's start from the first one, which is R is equal to K 2. Now, the power of A here is what now? Is 2. While the power of B here now is 1. Because it is not written. But we know the power of B here is what? 1. So 2 plus 1 now. So the order of this reaction, now is simply equal to 2 plus 1 to give me what now? 3. So this is a third order reaction. You see that it's very, very simple. Now, the order of this reaction in question number 2 here is what now? Is 1. So this is a first order reaction. Now, the order of this question 3 here now is 4. It is 4, which is a fourth order reaction. 2 plus 2 is what now? Is 4. Now, the last one for here is this. R is equal to K. For your arrow, for your rate of the reaction to be equal to your rate constant, it means that the order is 0. How? If I'm having something like this, let's say I'm having R is equal to K. If I put any letter here, any reactant here, 0, right? So anything raised to power 0 is what now? Is 1. And because it is 1, the rate is simply equal to what now? My K. That is why the order of this reaction is 0. Why? The rate of the reaction is equal to your rate constant. If that is so it is a 0 order what? Reaction. And this is how simple it is. Now, in our next video, I will talk about a major calculations about it. Please do like, comment, and share. And if there's any question or whatsoever, do it to let me know. Thank you, and God bless you.